The debate over whether light is a wave or a stream of particles goes back many centuries. In the 17th century, Isaac Newton believed that light is a stream of particles. This theory is known as corpuscular theory. Newton was so revered as a scientist that it was nearly impossible for anyone to dispute with his theory. In 1801, Thomas Young presented a serious challenge to Newton's ideas on the nature of light. Young was a true polymath with interests ranging from physics to Egyptology. He was born in 1773 in Milverton in southwest England. In 1801, Young was appointed to a lectureship at the recently formed Royal Institution in London, where he gave a series of lectures on a variety of topics. Young saw some problems with Newton's corpuscular theory. For instance, he noticed that at interfaces such as that between air and water, some light is reflected and some is refracted. But the corpuscular theory can't explain easily why that happens. The corpuscular theory also has trouble explaining why different colors of light are refracted to different angles. In May of 1801, while pondering some of Newton's experiments, Young came up with the basic idea for the now famous double slit experiment to demonstrate the interference of light waves. The demonstration would provide solid evidence that light was a wave, not a particle. Figure shows a schematic diagram of Young's famous double slit experiment. To have light from a single source, Young used the sunlight passing through a very narrow slit in a window covering. Nowadays, we use light of a single wavelength called monochromatic, meaning one color. This beam of parallel rays falls on a screen containing two closely spaced slits, S1 and S2. The slits and their separation are very narrow, not much larger than the wavelength of the light. If light consists of tiny particles, we would expect to see two bright lines on a screen placed behind the slits. But instead, a series of alternate bright and dark fringes are seen. Young was able to explain this result as a wave interference phenomenon. To understand why, Young compared this pattern with the interference pattern produced when two rocks are thrown into a lake or when sound from two loudspeakers interferes. He simulated interference pattern of water waves using a ripple tank. Young also used his data to calculate the wavelengths of different colors of light coming very close to modern values. This was convincing evidence for the wave nature of light. Despite Young's convincing experiment, people didn't want to believe Newton was wrong. Disappointed at the response to his research on light, Young decided to focus on medicine instead of physics. The basic double slit experiment that Young has proposed has not only used to show that light acts like a wave, but also to demonstrate that electron can act like waves and can create interference pattern. Since the development of quantum mechanics, we now know that light is both wave and particle, not simply one or the other.